In this video, we're going to be looking at number series. Some of the material has been taken from our verbal reasoning books, which you can find via the link in the description, alongside a free PDF with 20 questions for you to try after this video. So let's get into it. These questions are about finding a relationship between the numbers in a series. You must complete the series by following a pattern. So here you've got 3, 5, 7, and 9. Now this is called an arithmetic sequence. So these types of sequences, probably one of the more basic ones. You can see here you've got a common difference of 2. So we've got 3, 5, 7 and 9, and then if you add 2 to it, then we get 11. So it's quite straightforward, that type of sequence, probably one of the more easy, relatable ones. Now let's look at another type of sequence that not many people talk about or know about. You've got alternate patterns. So that's when there's one change applied to the odd terms in the sequence, and then you've got another change applied to the even terms in the sequence. So you can see here we've got 2 to 4, we're adding 2, 4 to 6, we're adding 2, and then from 3 to 6, we're adding 3, and then from 6 to 9, we're going to be adding 3 again. So actually we're going to add 2 here, and that's how we're going to get 8. Remember, you may not always be filling in the final numbers in a series. Sometimes numbers are missing from the beginning or middle of the series. There are other types of sequence that will be encountered in this question type. If you want to watch another more in-depth video on sequences and the different types, click here and you'll be able to see it. Let's go into some examples. So here we've got 2, 2, 4, 12, 48. Now this sequence is actually quite complicated. We've got a type of geometric sequence or multiplying sequence. So you can see we're timesing by 1 to get to 2. From 2 to 4 we're timesing by 2. From 4 to 3 we're timesing by 3. No, 4 to 12 we're timesing by 3, and then from 12 to 48 we're timesing by 4. So if we do 48 here to get our final sequence, we're going to have to times by 5. So that's 240. Second question. So let's look at this one. This one is an arithmetic sequence because we've got a common difference between these. So you can see each time I'm adding 3 on. So many of the sequences that you can expect to see at Key Stage 2 will be arithmetic sequences, but in the 11 plus they will try to throw in some more difficult examples, but you should be well aware of this type of problem. So you can see the next term we're going to add 3 to 16 and then we'll get 19. Let's look at 3. So we've got 3, 4, 7, 11 and then 18. This type of sequence is actually quite hard to spot. This is a Fibonacci-like sequence. So that's when a term in the sequence is formed by the previous 2 terms. So for instance, 3 plus 4 gives you 7. 4 plus 7 gives you 11. And then 7 plus 11 gives you 18. So you'd have to take 11 and add it to 18 and you get 29. So that'll be the next term in the sequence. Let's move on to another set of examples. By no means this is an exhaustive list of examples. You could have prime number sequences quite easily. So be aware of the different types of mathematical facts that you need to know. So let's look at 4. So you've got 2, 4, 8, 16, 32. You can see each time, this is a type of geometric sequence. So each time we're timesing by 2. So we're going to get 64 if we times 32 by 2. Let's look at our next one. So in this case, we've got something called a declining arithmetic sequence because it's going down in constant differences. So from 26 to 19, we're minus 7. From 19 to 12, we're minus 7. From 12 to 5, we're minus 7. From 5 to minus 2, we're minus 7. And then minus 2 minus 7 will be minus 9. And then let's look at our next sequence. So this is what I was talking about before. You've got to be aware of the different types of numerical facts. It's quite difficult to spot the pattern if you were to look from term to term. You've got 1, 4, 9, 16, 25. So these are actually special numbers that you should recognize. They're called square numbers. That's when a number is times by itself. So 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16, 5 times 5 is 25. So our sixth term in the sequence will be 6 times 6, which is 36. Let's look at a final example. So I wanted to have one alternate sequence just so you can see what to do. Again, they're quite difficult to spot, but if the pattern doesn't seem to make much sense, then it could be an alternating sequence. So here we've got 3 to 9, that's going to be plus 6. 9 to 15, that's also going to be plus 6. So we're going to have something else happening with our even terms. So we've got 4 to 5, which is plus 1. And then this is our sixth term, so that's going to be an even term, so part of the even term pattern. And here we're going to have plus 1. So it will be 5 plus 1, which is 6. I hope you found that useful. Don't forget you can download the free 20 question PDF via the link in the description, as well as a copy of the full verbal reasoning books. To watch another verbal reasoning video, click on one of these boxes over here. And don't forget to like and subscribe.